Hello, and thank you for joining me on this video as we look at how to do calorimetry calculations. So the question up above, question on this slide says a piece of metal weighing 59.047 grams was heated to 100 degrees Celsius and then put into 100 milliliters of water, initially at 23.7 degrees Celsius. The metal and water were allowed to come to an equilibrium temperature determined to be 27.8 degrees Celsius. Assuming no heat loss to the environment, calculate the specific heat of the metal. Okay, so to do this, we have to look at what we know. For starters, we know a mass of the metal. Oops. Let's try that again. We know a mass of the metal. Let's do this. Which is 59.047 grams. We know that the initial temperature, TI was 100 degrees Celsius. We know the final temperature ended up being 27.8 degrees Celsius. And we are looking for the specific heat. So I'm looking for C. So to do this, we're going to use the equation Q equals MC delta T. Hey, but I don't know a Q either. At least at this point, we don't know a Q. So I have two unknowns. So I can look at the rest of my information. I know that I put it into 100 milliliters of water. Because I put it into water, that's really important because I know the density of water equals 1 gram per milliliter. So I can convert this, I can take this times 1 gram per milliliter. And I know that I have 100.0, that's a point, grams of H2O. Okay. I also know that I had water at an initial temperature of 23.7 degrees Celsius. And it reached a final temperature also at 27.8. The last little bit that I know about water is I know that water has a specific heat or a C value of 4.184 joules per gram degree Celsius. Or I could use calories, which is 1 calorie per gram degree Celsius. And it's based on this, I can then find my Q value. So I'm going to set this up. So Q of the water equals the mass, which we said was 100 grams, times the specific heat. I'm going to use 4.184 joules per gram degrees Celsius times my change in temperature, my delta T. I went from 23.7 to 27.8. So I gained 4.1. So I can do 27.8 final minus 23.7 degrees Celsius. I'm going to plug all that into a calculator, and I'm going to come out to Q being equal to 100 times 4.184 times, and if we take 27.8 minus 23.7, we get 4.1. And so my Q value is going to be 1,715.44. And based on significant figures, I'm going to use 1,715. Q was 1,715 joules. So now I can put that in because that's the water gained this much energy. It had to come from somewhere, so it had to come from this substance, this metal. So I know that my Q up here is 1,715 joules. So now I can solve this equation for C. So to get C by itself, I'm going to divide both sides by m delta T. So I end up with C equals Q divided by m delta T, and then I'm going to put numbers in. So C equals 1,715 joules divided by my mass, which was 59.047, times my change in temperature. My final was 27.8 minus my initial, which was 100.0. I'm going to put a second set of parentheses to make sure all this is on the bottom is multiplied before it's divided. So if I take 1,715 and I divide that by 59.047 and then divide that again by the subtraction of 27.8 minus 100.0, I get a final answer of negative, C ends up being, in this case, right now we're looking at C is negative 0.4023. Negative 0.4023 joules per gram degree Celsius. Okay, but what I forgot to do, what I didn't do, is the water gained energy. Water gained 1,715, which means that my metal had to lose this, so Q should have been negative here, which would have made this negative, which would make this a positive 0.4023 joules per gram degree Celsius. And so there is my calculation and my calorimetry question for calculating specific heat of the metal. And then from there, we could go ahead and identify it if we had a chart with given specific heats. We could figure out what metal we're working with. But that is your example, and that should help you answer your calorimetry questions that you have assigned in class. Thank you for watching, and I will see you next time. Good luck with your questions.